Let's review the iron cementite diagram. Here it is. Again, we're not really interested in this portion of the diagram. For our purposes, we want to look at this portion down here. I'd like to stay within the steels range. Over here is the cast irons. And you can see down at the bottom, steel is between 0 to 2% are steels. And then they have the cast irons. We're going to bypass the cast irons and just stay with the steels. Anything less than 0.8% steel, 0.8% carbon, is a hypoeutectoid steel. Anything greater than 0.8% is known as a hypereutectoid steel. If we look at the phases that are occurring in this phase diagram, the phases are, they're written here, austenite, ferrite, and cementite, which occurs here at 6.67% carbon. If I were to include microstructures, I'm trying to use this particular phase diagram, microstructures. Microstructures are at the 0.8% carbon, that has a special name known as perlite. Other microstructures which are not on this diagram is martensite. And another one would be bainite. Again, it's not on this diagram. These are microstructures and these are phases. The thing about microstructures and phases is everything comes under the heading of microstructures. So microstructures here includes all of this. These are all microstructures, but only these are phases, which are a part of this diagram. I'll repeat that. Microstructures is everything, but phases are only these items. Let's look at the microstructures now in total. I'll just simply redrew that diagram. And here we have it. At the 0.8% mark is a microstructure called perlite. If I were to look into a chunk of steel that's made between 0 and 0.8% carbon in this field, the microstructures that I would be looking at would be a combination of ferrite. If we go all the way to the left, we see ferrite, and all the way to the right is perlite, and I've redrawn them here. There's your perlite, and there's your combination of ferrite. All depends on how much carbon we have. The greater the carbon, the greater the amount of perlite. The less the carbon, the greater the amount of ferrite, or the less the perlite. Right here at 0.8%, if I were to look at the microstructures, take a piece of steel, that will be 1080 steel, section it in the annealed state, and look at it under the microscope, etch it. It would be 100% perlite. And perlite, you know, is laminar structure, combination of ferrite and cementite. So it's made up of two phases. In combination, the two of them is called perlite, and that is a microstructure. If I were to look at the right-hand side of this, and at the hypereutectoid side, and again, I want to see the microstructures, and I would take, say, 1.1 or 1% carbon, and look at this area, or a steel made from 1%, 1.1. This is what I would see. In the annealed state, it would be at grain boundaries. And at the left-hand side, the microstructure is perlite, and on the right-hand side, the phase is cementite. So I would see perlite. It would be all perlite. And cementite will be at the grain boundaries. So I'm just going to simply draw cementite will be growing here at the grain boundaries. Combination of perlite and cementite for hypereutectoid steels. Having said all of this, let's have a look at experiment number 8. Has some questions. What is the microstructure of 1020 steel above 950 degrees Celsius? Using our phase diagram for 1020 steel. This is 0.5, 0.1, 10, 20. Going up to about 920 degrees Celsius. Microstructure is it's in this field right here. We already know what that is. What is the maximum amount of carbon that can be dissolved in this structure? Going back here to the diagram, the maximum amount of carbon that can be dissolved by this structure is 2%. It goes all the way to the left right here, going all the way down is 2%. What is the name of the microstructure at 0.76 weight percent carbon? 0.76 is the same as the 0.8. We just simply rounded to 0.8, but this is also 0.76%. The name, that structure. What phase is present in a eutectoid steel below 727? Well, here's the 727 line, and this is known as the eutectoid steel. 1080 is known as eutectoid steel. And the name of that eutectoid steel, the microstructure for that eutectoid steel is I said, what are the phases present in eutectoid steel? So the phases of perlite, combination of the two. And let's go to this. What are the microstructures present in annealed hypoeutectoid steel at room temperature? Here are the microstructures present for hypoeutectoid steels. And what are the microstructures present in annealed hypereutectoid steels? Looking at the diagram again, this will be the hypereutectoid steels. And what are the microstructures present in this region? When a medium carbon steel is cooled very rapidly from a temperature above A3 to room temperature, what structure is expected to form? Now, we did that in the lab. If you bring something up here to this field, austenite, and then you quench it rapidly in water, that structure that is formed is called martensite. What is the definition of plain carbon steels? This is a plain carbon steel right here. No alloys have been added to it. The 1 represents no alloys being added. The second number represents the percentage of alloy being added. In this case, it is 0. And the 80 represents 0.8% carbon. And what is the difference between hardness and hardenability? I will have to leave that for you to research. And what is a Charpy test? Well, we did that here in lab number 8.